So once again, what are we doing? We look at the entire expression. We ask ourselves, how many terms in the expression? How many terms? One term. One. Why? Because the line makes it one. The division line makes it one. Secondly, in the numerator, how many terms? Well, if you look at the bases, this base 2, multiply, square root, multiply, makes it 1. Multiply combines terms. In the denominator, how many terms? 1. So here we are happy because we have multiply and divide alone in the entire expression. So then we are going to say, okay, Mr. Bedmess, I'm obviously lying in my bed, but of course, since there's no addition and subtraction between the bases, the AS part, I'm not even going to bother myself. Let's get out of bed. B brackets, E exponents, D division. Remember, E also stands for exponents and roots. And let's not forget this guy. Very helpful, this guy, in situation where we want to convert roots to rational exponents. Okay, so let's go. Brackets, we have none, so we are going to pass. E exponents, a few. So let's come here and rewrite 2 to the power x minus 2. Convert composite bases to prime bases where possible. That's something also that we always observe if we have numerical bases. Convert all composite. What is composite numbers? Composite numbers are numbers that have more than 2 factors. For instance, 25 has more than 2 factors. 2 is not composite. 2 is a prime base. Okay, a prime number is a number that has 2 factors only, 1 and itself. So the factors of 2, for instance, are 1 and 2. 25 is not a composite base. A prime base. It's a composite base. It has more than 2 factors. So we are going to convert this. But first, let's just deal. 2 to the power x minus 2, you are fine. 25 to the power x is going to be 25. Convert this to exponent, x over 2. This numerator, square root, denominator, the 2. Are we together? Feel me, my brothers and sisters? We applied this rule. This guy is going to be very useful for you. I'm telling you guys, very useful, this man. He's a useful man. Okay? He's a useful man. Very useful man, this man. So let's not forget him. Next, times 10. All right? We are going to convert him 10. When we convert him, all right, I guess just like we could have converted 25. Okay, maybe let's do it one at a time. We'll do the conversion just now. Okay, let's do the conversion of all these composite to prime now. 2 to the power x minus 2, because at least we were able to convert the root to exponent. So 2 to the power x minus 2, let's go to 25. 5 squared. (25) is 5 squared. How do we know? If we don't, 25 equal shift Mr. Facts 5 squared. Okay, this base is prime. This base 5 is a prime number. 3 raised to the power 2. So we can just write the 5 squared, then x over 2 outside. Okay, 10. Let's go to our calculator. 10 is written as 10 is equal to shift fact. We can express 10 as such. And whatever we convert, guys, we make sure we place it in brackets. Why are we doing that? So that the law that follows can be applied, where we distribute the exponents to each respective base. Okay. Exponents and surds jabulile for grade 11. 8. 2 to the power 3. Press 8 in your calculator. You press equal, you press shift, you press fact, you'll get 2 to the power 3. Then you put it in brackets, you write x minus 1 outside. 5 is already prime. No problem. So we are still here. We have not gotten out of bed yet, right? We have not gotten out of bed yet. Right? We have not gotten out of bed yet. Brackets, all right? Exponents. There's that law now, this one, that we can apply, where if the relationship between the bases is one of multiply, we distribute the exponents. P times the m for the a, p times the n for the base b. So let's come and do that then with what we have there. X minus 2, 2 to the power x minus 2, no problem. 2 times x over 2. This 2 and this 2, they cancel. We're left with 1 and 1 because 2 divided by 2 is 1. That leaves us with 5 to the power x. We remove the bracket that way. Base 2, that's raised to the power 1. Remember, it's like God, unseen but present. So we are going to take this 1, distribute to the x, take the same 1, distribute to the negative 2. So we get 2 to the power x minus 2 as a result. 1 times x is x, 1 times negative 2 is negative 2. The 5, we do the same thing. There's a 1 here. So it's going to be 5 to the power 1 times x is x, 1 times negative 2, negative 2. All over what? Do the same thing here. So my chat, what will be the answer there? Let me see. I want to see what you guys... 2 to the power 3 raised to the power x minus 1. In the comment section, will you grace me with what you believe is going to be the outcome? 2 to the power 3 into x minus 1. Okay, I see you, Ghana. I'm guessing that's the exponent. All right. I see you as well. I see you, that melanin girl. As melanin and chocolatey as ever. Yeah. Okay. We good, right? All right. So that means we distribute 3 times x, 3 times negative 1. This is something sometimes learners forget. They distribute the 3 to the x, and then they don't distribute the 3 to the negative 1. So this is like a monomial by a binomial. So let's always make sure that we distribute the exponent to completion, okay? So 2 to the power 3x minus 3. Very good, guys. Very proud of you there in the comment section. Did very well. Times 5 to the power what? 2x. Exponents done. SNL done. Distribution done. Law, this one done. Next step, we are getting out of bed now. Division. Division of what, guys? All right. Law number 2. Division of bases that are the same. Okay. The only bases that we have here are base 2 and 5. So I'm going to collect those individual bases. Let's start with base 2. If you want, you can start with base 5. Doesn't really matter. Now I'm going to do a collection of all bases for their respective exponents. Base 2. Same base. Base 2 at the top. No sign change. X minus 2 as it is. At the top, bases are the same. When we are multiplying, we do what to the exponents? Add the same thing. There's no sign change. base 2 in the denominator. Guys, in the denominator, if we transport this guy up to the numerator, who changes? Everyone changes. So that means 3x is now going to be negative 3x. Negative 3 is now going to be positive 3. The sign change, because this is a direct application of these two. All right, the sign 3x, negative 3x. The sign of negative 3, positive 3. This is me just collecting everyone for base 2, so that I deal with base 2, done, did, finished. Multiplied, okay, by what? Base 5. Now we collect all the base 5 exponents. He is at the top, so he stays as he is. Multiplied, we are adding. He is at the top, stays as is, adding x minus 2. He is at the bottom. At the bottom, we experience what we call the what, guys? The sign change. So 2x is negative 2x. Then we are out of bed, officially and finally. Division together with multiplication was accommodated in this process, because same bases divided, we subtract exponents. Same bases multiplied, we add. Sign change, division, same signs with addition. With multiplication. All right. Any questions so far, guys? You did such problems, at least from this stage, grade 10 as well. So it's not a new concept. It is really not a new concept. But if you are struggling, okay, one needs to indicate ish, All right. And maybe some of you do it a bit differently, in that you do the numerator and then later on you do the denominator. Guys, at the end of the day, the answers will be the same. All right. Me, I just prefer to collect everything using law number 1 and 2. I prefer to do that. Then I know with law number 2, with the division, all I am doing is a change of signs. This that was positive is now negative. This that was negative is now positive. I just do that with all the denominator. This that was positive is now negative in the numerator. Now we add like terms. Grade 8 and 9, you learned how to add like terms. X plus x is a like term. X plus x, x plus this x minus 3x. That gives you negative x. So x is not going anywhere. X is here to stay. Negative 2 minus 2 is negative 4 plus 3. That is negative 1. Then we go to the 5. X plus x is 2x minus 2x is 0. Then you have 0, then that minus 2. As we conclude, the bases are all negative. Answer 1 over 2 to the power x plus 1 times 5 to the power 2. Which is 1 over, we then settle it, 25. Split, this is 2 to the power x times 2 when you split these two, which gives you 1 over Now you can multiply this 25 with this 2. That's 50 times 2 to the power x. So that's an answer simplified completely. If they would have said to you, leave your answer in exponential form, then I guess, guys, at the end of the day, this is actually leaving our answer in the simplified exponential form. Okay, yeah. All right. Any questions, guys, at all that you guys have? If you have, ask. If you don't, I'm happy for us to continue. So please, guys, we go all through this very nicely and swiftly until we get to the very dead end. This is the situation. I've done 3 consecutive problems where in these problems, that last step, 3, 2, 1, this step, Ghana 2 to the power negative x minus 1. Do you see the exponents for both are negative? We are multiplying. The relationship is one of multiplying. This base also has a negative exponent. So what is going to happen to these bases that are raised to negative exponents? They are all going to go where? Down. 5 to the power negative 2 is also going to go down. Who gets left behind at the top? 1. Okay, because 1 is multiplied to all of this. You don't see 1, but 1 is there. It's multiplied to all those bases. All right. So 2 to the power negative x minus 1. This exponent changes to positive when it goes down. This exponent changes to positive when it goes down. What about 5 to the power negative 2? He also changes to positive exponent. Guys, remember, what am I applying here? I am applying this notion of if a is raised to the power negative n, my final answer needs to be a positive exponent. So the base will change its position from numerator to denominator. The exponent changes from negative to positive. That's what happened here. 2 is raised to the power negative x minus 1. Moves to the denominator. The exponent changes from negative to positive. 5 is raised to the power negative 2. Since the relationship is multiply, this movement happens freely. There's no plus or minus in between the bases. That's why it moves freely. We leave 1 at the top, and then 2 to the power negative x, positive. Negative 1, positive. Negative 2, positive. Okay. Hey, I hope you are with me, guys, here. How important this is. Then, as I said, 2 to the power x plus 1. The reverse of 2 to the power x plus 1 is the same thing as saying 2 to the power x times 2. I am splitting this to the original form. You multiply same bases, 2 to the power x and 2 to the power 1. What do you do to the exponents? You add them. This is just the reverse. By splitting, I see that there's 25 and this 2. 25 and 2 can be multiplied to give me 50. Then times 2 to the power x. I can't multiply the 50 and this 2. This base is committed to the variable x, and I don't know what the variable x is. So this 50 is simply multiplied to 2 to the power x. I can't multiply the 50 and the 2 and say 100 to the power x. That's wrong. 50 is multiplied to 2 to the power x. I can multiply though this 25 and this 2. This 2 is freestanding. I can multiply it. Okay. KG, when am I going to end the live? I'm going to end the live at 10:30. Okay. So yeah, if you need to go, please go. Like I said, link of the YouTube channel is in my bio. I upload the live lesson as it is in my YouTube channel. You can rewatch whatever you missed. If you need to go to church, please. Okay, so guys, all the problems that we've done above had to do with multiplication and division between bases. Now let us step into another world for a little bit, so that we can see the difference. Look at this problem. The fourth problem in this life. 2 to the power x plus 1 minus 2 to the power x minus 1 over 2 to the power x minus 1. So once again, we look at the entire expression, grade 11s. Okay, we look at the entire expression. Then we ask ourselves how many terms in the expression. The line means one term. In the numerator, how many terms? Let me stop there. In the numerator, guys, how many terms do you see? The numerator. I'm simply asking, in the numerator, how many terms do you guys behold? How many terms are in the numerator? Yeah. That melanin girl, thank you so much. Okay, there are 2 terms in the numerator. Why do we say 2? Plus and minus is what separates terms. Between bases, what separates terms is a plus and a minus sign. So that's 1 minus sign, that's 2 terms. If we have 2 terms, it means now we can't apply law number 1 and 2 as we usually would do. We can't, guys. It's not possible to apply law number 1 and 2 if there's a minus sign between terms. What we need to do now is we need to actually look at a different approach. BEDMAS is still in our heads, but of course we don't have brackets. We have exponents, but not with a bracket involved. Division is still there, but unfortunately we have subtraction in the mix as well. So it calls for a different approach. In the numerator, what we do is we split the base, applying law number 1 in reverse. We split the base using law number 1 in reverse. So you have 2 to the power x plus 1 here. This becomes 2 to the power x, 2 to the power 1. That's for your first term. Your second term, you have 2 to the power x minus 1. So you write it as 2 to the power x times 2 to the power negative 1. And then in the denominator, you have 2 to the power x minus 1. You can write it as 2 to the power x times 2 to the power negative 1. Something we note very quickly is that base 2 to the power x, base 2 to the power x in this particular situation exhibits an expression of 2 terms in the numerator where we have the same common what? Common base with an unknown variable. So we have a common base with an unknown exponential variable, or you could say an exponential variable. So then that means factorize. Now, different problems, some require you to take out that highest common factor, common base with the unknown variable. There are situations where that factorization is what is needed. Or there are some situations where a different type of factorization is needed. In a situation where we can see that this is a quadratic trinomial, and we are going to be looking at such a example very soon. So here, this one has a highest common factor, which is the common base with the unknown exponential variable in this situation, that 2 to the power x. So what do we do? Highest common factor, guys, whenever we have a highest common factor in an expression, what do we do to the highest common factor? We take it out. So let's take him out. 2 to the power x. Let's take him out. Take him out on a date, right? Yeah, take him out on a date. Very important to take him out on a date. Then what's left on the left hand side if we take out 2 to the power x? We are left with 2 to the power 1 on the left. What's left on the right hand side? We are left with minus 2 to the power negative 1. We close that bracket. That is all going to be over what? 2 to the power x times 2 to the power negative 1. Now what's nice is that when we look at the newly formed fraction, initially here at the top we had 2 terms, but when we take out 2 to the power x and then we have a bracket, my question is, in the numerator now, how many terms do we have? Majajitini, thank you. We have 1 term. So what does the factorization do? The factorization changes 2 terms to become 1. So when we take out a common factor, guys, there is something we are essentially doing. We are changing the situation with the fraction so that that can allow us to apply the laws for what is outside the bracket in conjunction with what we see in the denominator. So the relationship that exists now is 2 to the power x is multiplied to all of this. Multiply relationship restored. In the denominator, multiply relationship restored, which means law number 1 and 2 can be applied for what is external or for what is common. So what we see here is that 2 to the power x and 2 to the power x can actually be cancelled because it is not across an addition or subtraction sign. It is actually with a relationship of multiply that has been created through factorization. Okay, remember that cancellation leaves us with 1 and 1. So at the top now we have 2 to the power 1 minus 2 to the power negative 1 can be written as 1 over 2. What did we do here? Remember, a base raised to a negative exponent can be written as the 2 goes to the denominator. Okay, so we have a fraction. Then at the top we have 1 over 2. That's all going to be over. We are left with, in the denominator, 1 over 2 as well. So all you do here is you can just grab your calculator now and you can actually work out 2 minus 1 over 2. In the numerator, we have 3 over 2. That 3 over 2, remember, what does this line mean? What does this line mean, guys? I just want to shortcut this process. What does this line mean? We get 3 over 2, obviously, in the numerator. What does the line mean? This line, what does it mean as far as our operations are concerned? Yes, it means divide. So 3 over 2 is going to be divided by what at the bottom? By half. Okay. And obviously, guys, 3 over 2, okay, we do the, is it KCF? Keep, change, flip. Okay, I learned this in the live. Learners taught me this whilst I was teaching a live lesson. That's why I'm saying learners are beautiful. Learners are powerful, I promise you. Don't mess around with learners. I learned this thing in the live. I did not know this thing. KCF. I thought, I was like, what are these people? Why are they bringing KFC into the live? And then I know KCF said, KCF what? No, you keep 3 over 2 as it is. You change divide to multiply, and then you flip the fraction. It's like, learners. Then, guys, it's simple. So you say 3 over 2 times 2 over 1. That gives you 3. Keep common factor. The learner said keep, change, flip. All right. Dem Taka Chili's official. You are misleading us, Wena. Leonard said, keep change, flip, my guy or my girl, whoever you are. So yes, guys, please. Nice. All right. Common factor type problems. Okay. Sticks, is this pure maths or maths lit? Maybe you should tell us, what do you see? Do you see pure maths or maths lit? Okay, but it's grade 11 anyways. Whatever it is, maybe Sticks, you can answer your own question there in the comment section. Is it pure maths or maths lit? 4 to the power n minus 9 to the power m over 3 to the power m minus 2 to the power n. Once again, another question. This one, it's really, you can see. So once again, what do we see here? Okay, it's not just multiply and divide, but we have what? How many terms in the expression? We have 1, because it's a fraction. If you look at the denominator, how many terms? How many terms in the denominator? Guys, in the denominator you have 2. In the numerator, we have 2. So that means we have addition and subtraction. We have subtraction in the mix. Okay. Now, for this particular one, we always know in our heads, if there's a minus and a plus, there's going to be some type of factorization that's going to have to be done. All right. Okay. But with this problem, we can see 4 and 9 are not prime bases. Here, look at this problem. The base 2 was prime. This base 2 was prime. This base 2 was prime, which made it so easy for us to split, because we could see there's something common when it comes to factorization. In our heads, the minute we see a minus sign or a plus sign, we think about factorizing. Something somewhere needs to be factorized. There's a type of factorization that has to be applied. So for this problem, the splitting and what is already prime helped us to actually apply highest common factor factorization, take out what's common, and then cancel. This one, base 4 and base 9 are not prime. So let's first change those composite bases to prime bases. What is 4, guys? Comment section, help me out. I need your help. 4, what is 4 as a prime base? And what is 9 as a prime base? We can't cross multiply KH4. Thank you, Clayton. Your Clayton is like giving me both. You don't mess around with Clayton, eh? 2 to the power 2. 3 to the power 2. Thank you, Clayton. Okay, thank you, Clayton. Then, of course, there at the bottom, we are still good, Moss. We are still good there at the bottom, no problem. We are still fine. All right. Now check me out, right? Then what I do is, there's something that I know about multiplication. A times B is the same thing as B times A. We say multiplication is commutative. This was a grade 8 concept you learned. Multiplication is commutative. That word, commutative, the order in which you place something with multiplication doesn't matter. 2 times n is the same thing as n times 2. So what I've just done here is I've written 2 to the power, the n, the squared. So I know there's 2 of these 2 to the power n. There is 2 of these 3 to the power m. This is something that I'd like to see, to know what is happening with the numerator. In the denominator, I have 3 to the power m minus 2n. Okay. If you look at this, 2 terms in the numerator. This squared, that squared. What do we call these 2? things. What do we call this term? Since it's raised to an even exponent, what do we call this term since it's raised to an even exponent? And what is this minus sign? Okay, because now I'm like, okay, I can't split, but there's a type of factorization that I can see at the top here. There's a difference here. This here is a something. This here is a something. What is this, guys? What type of factorization? Tender, difference. Beautiful Ghana, difference. Clayton, difference. No question mark. Clayton, be confident, my guy. Difference. Difference of two squares. Now, the grade 10 learners that I've been teaching have been doing factorization, right? When there are rules attached to factorization, and the rules of factorization say whenever you factorize, the rules that you follow is that step number one, for two terms when you are factorizing, you need to first establish how many terms there are. So in the numerator, there are two terms that we know for sure. Secondly, after you establish how many terms there are, you need to then ask yourself, should I apply the sign change rule? Is it necessary to apply the sign change rule? Now, some of you are going to be like, what does this guy mean by the sign change rule? Is it necessary to apply the sign change rule? Do we know what the sign change rule is? And when you are going to apply the sign change rule, you must look at the situation, not only here at home at the top. You must look at the situation at the bottom. And if the situation at the bottom is saying, hey, sign change rule is key, you better apply it. So the situation at home is informed by the situation abroad. Look at the situation at the bottom and ask yourself, is it necessary to apply the sign change rule? And maybe some of you are sitting here and are asking, what is the sign change rule? What does this guy even mean by that? Sign change rule for what? Guys, what I'm saying by the sign change rule, if you have, let's say, m minus n, right? Let's say you have m minus n and you have n minus m. And the question says simplify. Okay, two terms. Okay, the sign change rule simply means this. You have m minus n. The sign change rule is this. The order of m minus n is not the same order as n minus m. But when you have a subtraction sign in between, you can do the following, for instance, in the numerator. Take out a negative sign in the numerator. Then you rewrite the order in the numerator as n minus m. Yes, you can do that, Clayton. You can do that. If you find working with exponents, you want to work with letters, you can let A be that and B be that. You can do that. Okay? But yeah, you can do that. That's fine. But then you just need to substitute back at the end. So guys, sign change rule, look at this. Took out negative sign. Then I change the order of the letters. That's odd. The minus sign just remains, guys. You just simply change the order. Why? Kaloku, you can see there's an n minus m and your wish is to get rid. But look, guys, sign change rule is only applied when there's a minus sign in between terms. You can't apply the sign change rule when there's a plus sign. You apply it when there's a minus sign. So I take out a negative and I rewrite this m minus n now as n minus m. Now guys, check this out. If I take this negative, I put it back to n. What's negative times n? Don't I get negative n? Yes, I do. Take this negative multiplied by negative m. Don't I get the positive m that I had at the beginning back? Yes, I do. So does the sign change rule change this thing in any way? No, it doesn't. Okay, we are still talking about the same positive m minus n. Okay, So like I said, you take out a negative sign. Why are you taking out a negative sign? Your interest is to actually have the same order that you see in the denominator. You take out a negative, change the order. Now it fits the mold of what you see in the denominator. And then what can you do now? You can cancel, because we are not cancelling across a addition sign. We can cancel the bracket. And then what does that leave us with? There's a 1 and a 1, and of course negative 1 divided by 1. The final answer is negative 1. This is what we call the sign change rule. SCR. It's like a procedure, not medical. It's not CPR. It's, when people are out of breath and they need to resuscitate them. It's SCR. A procedure we perform so that we can form same brackets. That is what the sign change rule is. So this thing of sign change rule is useful in many aspects in mathematics, right? Because in situations like this, for instance, okay, I'm asking you, if you look at the two terms in the numerator, you first ask yourself how many terms there are. 2. Then, second question, should we apply the sign change rule? Is it necessary to apply the sign change rule for this particular expression in the numerator? Is it necessary? Guys, we only apply the sign change rule if it's necessary. If not, we move on to the next question and we ask ourselves, is there a highest common factor? And then if not still, after that, then we ask ourselves, what other type of factorization can we apply? That's where difference of two squares comes into picture. That's where trinomial factorization comes into the picture. That's where cubic factorization comes into the picture. That's where quadratic trinomial factorization comes to the picture. Okay? So that is like the order in which we go. Okay. All right. Does that make sense, guys? That is the order. Comment section. What do you have to say? I've explained what the sign change rule is. So is it needful that we apply the sign change rule in this situation? Do we need to apply the sign change rule, or is it not necessary? Okay, look at the order. 3 to the power m is first, minus 2 to the power n. But here, look, other way around. Okay, do we need to apply the sign change rule? We have minus and we have minus. Do we need to apply? Do we need to get the order right? Or are we fine? We don't have to. We are good. Sign change rule needful? Okay, now I'm scared because people are silent. Like it's silent, silent, silent. No response. Circling course. Definitely we have to. We should, guys. There's no other way, right? We have to apply it. So what I do then is I take out a negative. Then I say 3 to the power m raised to the power 2 minus 2 to the power what? N raised to the power 2 over 3 to the power m minus 2 to the power n. Sign change rule has been applied successfully. Then I look inside the bracket. What type of factorization is this? It's a difference of what? 2 squares in the right order, because it will prepare cancellation. So now remember, with difference of 2 squares, we open 2 brackets. All right. Minus, we put a plus and a subtraction sign. 3 to the power m squared, the square root of this gives us 1 3 to the power m here, and another 3 to the power m, because remember the multiplication of 3 to the power m is what is going to give us back 3 to the power m squared, or 3 to the power 2m. Then the 2n squared, 2 to the power n times another 2 to the power n is what is going to give us 2 to the power n squared. What is that all going to be over? going to be over 3 to the power m minus 2 to the power n in brackets. We make it 1. We make it 1 as well. All right. Okay, having taken out a common factor of 1. 1 is outside here. Here, negative 1 is outside. Now, that sign chain rule assists. Okay, so we applied SCR. Then we applied dots in the denominator, highest common factor, taking out 1. And now it's very straightforward. The relationship, how many terms at the top? 1. How many terms at the bottom? 1. Cancellation can happen for common brackets. So that's why the sign change rule was so pivotal and important in our process of how we work. We are left with negative into 3 to the power m to the power 2n. Then we simply distribute the negative inside the bracket to get an answer that is simplified of negative 3 to the power m minus 2 to the power n. And that is our final answer. Okay. Questions? Okay. So those that decide to use K or P, other letters, you can do that, but don't forget at the end that your answer must not be in terms of those letters. It must be in terms of the exponents. So at the end, you need to substitute back. Okay. Someone did indicate in the comment section, so what if I let A be equal to this 3 to the power m and let B be equal to 2 to the power n? And then I use the A and the B to simplify. Okay. I think it was Clayton. Okay. That is fine. Okay. That is fine. Okay, you can find the working of the exponents by letting the exponents be a variable, and then you simplify from there. But yeah, for me personally, I don't particularly like that for myself. Okay, though it works, because learners sometimes forget to substitute back at the end, and then they lose marks for not writing the answer in terms of the exponents. Because they think that once they get that answer in terms of that A and that B, that's the answer, and they forget to substitute back. So rather, yeah. So this is one type of question where you have to take out a common factor, so highest common factor factorization. This is another type where you have to apply difference of two squares factorization. So you see the factorization is coming back. Now, then the grade 10 learners wonder why it's so important to understand the basics of factorization. And if those basics are not solid in grade 11, then guys, my question is, how in the world are you expecting to do well in maths? Okay, so with just 3 minutes left, I'm going to do the very last question for the day. Okay, so that at least the exposure is quite a bit, and then yeah, I'm going to let you go because I also need to go. There's things that I need to do, church that needs to be attended. Okay, at least I attend church at noon. Yeah, so I have to have at least the next 30 to 45 minutes to prepare and go. Okay, last one. 4 to the power x minus 3 times 2 to the power x minus 4 over 2 to the power x plus 1. Now this question is even more different from the first two. But when we look at it, how many terms are in the entire expression? There is 1. In the numerator, how many terms do we see? We have 1, 2, 3. In the denominator, we have 2. Monty is like saying why 3? Because this problem has 3. What a question. Okay. terms are separated by a minus or a plus sign. So 4 to the power x, this is a minus sign that separates 4 to the power x and this term. This is 3 times 2 to the power x, that's one term, because multiply combines terms. This is another minus sign, this is the third term. Okay, then in the denominator, how many terms? 2 to the power x, this is plus 1, there are 2 terms in the denominator. Okay, hopefully now Monthly you understand. Didn't see the dot? Well, the dot sees you. Okay, there's the dot. Let's just make sure that it's clear now, that you can see it well. Okay, so 3 terms means we have a trinomial. And that's on the 4th of January. Yes, yes, Pasadena. Yes, indeed. Are you happy? Are you okay? Seems like you're stressing there. I see that face that you've written there, January at the end. Why are you weeping? Okay, so if we look at the denominator, 4. 4 can be written as 2 to the power 2 x. 3 times 2 to the power x minus 4. So I'm looking at where the variable is 2x, where the base is, all right? This is all over 2 to the power x plus 1, and I know there's some type of factorization I'm going to have to apply here. So the first question had highest common factor factorization. The second question had difference of 2 squares. This question, we have a trinomial, and what we observe, guys, is that for different terms, for what? For different terms that have the same base. Remember, this is your first term, this is another term. But for different terms where the base is the same, there's something that we are observing with the same base, the same prime base for different terms where the exponent is concerned. If you look at the coefficient of x here, it's 2. If you look at the coefficient here, it's 1. So we have a coefficient of 1, we have a coefficient of 2. So this is 2 times this. This is 2 times that. The minute, guys, you have a situation of 1, 2, 3 terms, where with your first 2 terms with the same base, the variable exponent, one coefficient is 2 times the other one. That immediately shouts to you that we have a quadratic trinomial. I repeat, 2 to the power 2. The focus here, Ghana, is to focus on where the variable is. We do not bother ourselves with the last term because it's a constant. What we are interested in is that these 3 terms are what we refer to as a quadratic trinomial. We have the emergence of a quadratic trinomial here. And maybe when I rewrite it, you are going to see that much more. So 2 to the power 2 can be written as 2 to the power x squared. So there are how many 2 to the power x's? There are 2 of them. Multiplication is commutative. That's why I'm saying when the coefficient of that x, you can see for the same base, one is 2 times the other one. That's when you know quadratic trinomial. Furthermore, because there's a constant term there, all right, which is a separate term that does not have a variable exponent. 2 variable exponent, the coefficient is 1. 2 has a variable exponent, the exponent is 2. So when one variable is twice the other, that immediately says to you we have a quadratic trinomial. So rewritten, 2 to the power 2x is written as 2 to the power x squared minus 3 to the power 2x minus 4. Hey, I'm sure you can see my trinomial. In the denominator, I have 2 to the power x plus 1. So I'm going to factorize this numerator. This is my square term. This is my k, and then this is my constant. So some people let k be equal to. Me, I don't really like the k thing, but I'm going to show you with the k thing, or if you decide to use another letter to factorize, because some people feel it's simpler when they do it like that, okay? So what we can do here at the top, we can see that there are 3 terms. This is a quadratic trinomial. How did we establish that? Because we saw that for one variable, the coefficient of that variable is 2 times, it's twice the other one. So that means a 2 to the power x and a 2 to the power x will give me back this. All right. Negative 4 is the constant. This negative means I'm going to have different signs in my bracket. All right. The highest factor in my bracket is going to have a negative sign. So I'm going to check the factors. The highest factor is going to have this sign. So I'm going to check the factors of 4. I have 1 and 4. I have 2 and 2. The highest factor we said is going to have a negative sign. The other one has a positive. So which one, when I add together, because the multiplication of these two, or the multiplication of these two, will both give me negative 4. So we have no problem with the last term. Multiplying will give me the last term. But which one, when I add, will give me negative 3? Is it 1 minus 4? Or is it 2 minus 2? What's 1 minus 4? 1 minus 4 is a negative 3. What is 2 minus 2? It is 0. So I think my factors that are going to feature in the bracket are definitely 1 and negative 4. So in the bracket, guys, the highest factor is going to have a negative sign, and then we're going to have a 1 there. I'm sure now you can see in the denominator something is the same. 2 to the power x plus 1. I put a bracket around it to make it one term, because that's me taking out my highest common factor in the denominator, which is 1. Now cancellation can happen without any problems. Do you see? This thing is not difficult. All right? Does that make sense, guys? Grade 11. This is not difficult. Okay, simplification of exponents. Quadratic trinomial factorization in exponents is made possible when you have 3 terms, 2, the base that is the same for your different terms exhibits for the variable a coefficient that is obviously 1 is 2 times the other one. If we multiply 1 by 2, we get 2. If we divide 2 by 2, we get 1. It's like even if we had 4 here and we had 2. This would also mean that the coefficient of the variable is 2 times the other one. It's like even if we had 6 here and we had 3. For the same base, the 1 exhibits the multiplication 2 times the other one. Here, if you have 8 as an exponent for the same base and you have 4 for this same base, it's still a quadratic trinomial. One coefficient is 2 times the other one. So this is how you know it's a quadratic trinomial. With that constant, it means you can factorize. Okay. So the factorization of this trinomial is 2 to the power x minus 4 into 2 to the power x plus 1. This is all over 2 to the power x plus 1. Now you can simplify and cancel, leaving you with 1 and 1. So your final answer is 2 to the power x minus 4. Guys, this is it. All right, for today. Thank you so much. I will see you tomorrow, grade 11th, with another live lesson where we are going to finish off these problems. These problems are in my TikTok page. All right, they are posted there. If you want to go ahead and do them ahead of me before I do them on the live, go ahead and go and do them. All right, the recent video, the picture video on my homepage is these problems. So I'll see you tomorrow in the morning. It's Monday, so I'll see you tomorrow morning at 7 a.m. Let's try 7 a.m. and finish off this thing. Okay. Thank you. Yeah, grade 10. Obviously, this here, what I've done so far, all these problems are relevant to grade 10. Okay. So you can try and do this one. I didn't do this one. Okay, I did this, that, this. Okay, I didn't do that one, number 5. I did this and that. I haven't done 8, 9, 10, 11, 12, 13, 14, 15. We'll be doing those tomorrow. You can go ahead and do them and have fun with them. Okay, thank you guys. It was great. And I hope you guys will have a beautiful Sunday. Please, if you can, do support the live creator. It's really helpful there when you guys can, if it's possible. If not, thank you for the likes. I think we ended the live on 12.1k likes today, so quite a phenomenal feat there. We had jumping between around 80 people in the live to 155, I think, at best. So it was a good live. I think definitely a good live. Hope you guys were able to gain a lot there. And yeah, I hope that will actually solidify your personal understanding of the maths. Go and practice more problems. You guys have textbooks. You go and grab those textbooks. You grab what's there. You just you live it up. You live it up, guys. You make sure that you are pumping, so that at the end of the day, remember, if the concepts are understood, now what is left is for you to apply the concepts through doing various problems. All right, so that at the end of the day you can see that, okay, I actually do know how to do this. It does make sense, and it is not just something that is vague and ununderstandable. Right? Yeah, this is how we started. We started off here with just questions that have only multiply and divide. Okay, only multiply and divide. Only multiply and divide. And then from there we transitioned into questions that have plus and minus. Plus and minus with the divide in the mix. We saw how splitting the base and highest common factor, when we have to apply highest common factor factorization, how that looks like. We saw when we have to apply sign change rule, dots, how that is like. And then lastly, when we have to apply trinomial factorization, how that is like. When we screenshot the other questions, that melanin girl, as I said, these questions are on the most recent picture video that I posted on my homepage. So if you go to my homepage, there's a slideshow of 2 pictures. They have these questions. They are there on my homepage. Okay, exponents and surds, game challenge grade 11. Okay, it's been picking up. I think it's been picking up. Okay, it's been picking up. People have really been, I think, checking out the picture videos, and it's just that there's no comments. People have only commented on the grade 10 picture slide video. Someone even said that, hey, these problems are too difficult, and I'm thinking this learner is going to grade 10, but he's saying grade 9 factorization seems difficult, and I'm like, we're going to be starting off on a very not so great foot. So please guys, the questions are there. There's even another page on the video itself of more questions. Go check out those questions. It includes also your surd and root questions, all right, which are based on the live lessons that we've covered. So I want you guys to actually go and make sure you verify and confirm what you have learned through the problems, doing them. So tomorrow we'll finish off these problems in the live lesson that we'll have. Okay, thank you again. Thank you again. And thank you again and again and again. Okay.
Okay, no, nice to meet you guys, ne? Yeah, we're just gonna try to look for like gaming now, trying to raise some roses and stuff.
Okay, bro. Thanks.
Wait, why you guys? Why are you scared to game us though?
I don't have lots of followers.
Hey, come on! It's not all about followers. You know, like people they'll be just joining. You never know; they might show some love to you.
Yeah, okay.
You think so?
Yeah, let's try it out. You never know. Trust me. Okay, so I'm sending the invite again to you guys. Hold on. Yeah, I've just sent the invite.
Okay.
Did you see it?
Yeah, I see it, bro. Thanks, bro.
Yeah, you have to accept it. Wait, when did you guys start this live thing?
Maybe 15 minutes. Why does it 15 minutes ago?
You see, Martha has 2.3k followers. She's lying. She's been doing this TikTok thing, guys. Oh, Ash, I saw the invite. Let me see if I can accept it. Why is it Martha declined? Martha is declining, guys.
I didn't receive anything.
Okay, let me try again. Let me try again. Okay, I've sent the invite to both of you guys. Martha declined your match invite.
I didn't. I swear.
Maybe it's doing automatically. You said it's one of your first lives. This one. Oh.
No, it's not.
Oh, it's not. Hey, Martha, where are you from?
I'm from Durban.
Oh, you South African?
Yes.
Oh, okay.
All of us, actually. I think Lerato and Whiskey as well.
Oh, okay.
Yes,
okay.
I'm from South Africa.
Yeah.
Oh, okay. Nice. It's all good. Okay, hey, been trying to send the invites, but I don't know. Okay, let me try for the last time. Let's see. Send invites.
Wow, it's gone again.
It's gone. I think there's something. I don't know. Maybe it's Martha settings, because on my side it's saying Martha declined. It's not even taking time. I know the one who's declining.